Today we're learning all about aspartame. The chemical formula for aspartame is C14H18N2O5. The molar mass is 294.31 grams per mole, and the density is 1.347 grams per centimeters cubed. The melting point is about 246 degrees Celsius. It's sparingly soluble in water and slightly soluble in ethanol. The IUPAC name is N-L-alpha aspartyl L-phenylalanine 1-methyl ester. It was discovered by James M. Schlatter in 1965, and it was initially intended as an anti-ulcer drug. Aspartame is used as a 0-calorie sweetener, even though it actually contains 4 calories per gram. However, it is approximately 200 times sweeter than sugar, so only a small amount is used to sweeten things, making the caloric value negligible. While not commonly used on its own, aspartame is often used in sugar-free products such as Diet Coke, sugar-free candy, and sugar-free syrup. It is not used as a baking sweetener, however, because it has a tendency to break down into its amino acids at high temperatures. Companies that sell aspartame are NutraSweet Company, Ajinomoto, Holland Sweet Company, and many others. Some benefits of aspartame are that it has no link to cancer. It can actually intensify fruit flavors in products such as candy and gum. It doesn't promote tooth decay, and it can allow those with diabetes to intake sweets without compromising their total carbohydrate intake. Some negative effects of aspartame are that there's association with weight gain, there's a risk of heart disease of intaking too much, a small effect of aspartate levels during breastfeeding, and a headache is a common symptom of intaking too much aspartame. While making aspartame, first a sample of pure culture of bacteria is put into a test tube containing the nutrients necessary for it to grow. When the population is large enough, they are transferred to a seed tank. L-aspartic acid and L-phenylalanine are produced, which are known as flavum and glutamicum. In the seed tank, the bacteria grows even further, and when enough bacterial growth is present, the contents of the seed tank are pumped into a fermentation tank. Next, the bacteria are allowed to grow and produce large quantities of amino acids. Since pH control is vital for optimal growth, ammonia water is added to the seed tank as necessary. When enough amino acid is present, the contents of the fermentation tank are transferred out so isolation can begin. The desired amino acid is segregated and purified in an ion exchange column. From this column, the amino acids are pumped to a crystallization tank and then to a crystal separator. They are then dried and readied for the synthesis phase of aspartame production. Phenylalanine is reacted with methanol, resulting in a compound called L-phenylalanine methyl ester. Aspartic acid is also modified in such a way to shield various portions of the molecule from the effects of further reactions. This ensures that further chemical reactions will occur only in specific parts of the aspartic acid molecule. After the amino acids are modified, they are moved to a reactor tank where they will mix for 24 hours. Afterwards, the temperature is raised to 65 degrees and maintained for another 24 hours. The reaction is cooled to room temperature and diluted with the appropriate solvent and cooled to -18 degrees, causing it to crystallize. The crystals are isolated and dried. These crystals are just intermediates, though. Finally, the intermediate is converted to aspartame by reacting it with acetic acid. The metal catalyst is removed by filtration, and the solvent is distilled, leaving a solid residue. This residue is purified by dissolving it in an aqueous ethanol solution and recrystallizing. These crystals are filtered and dried to provide the finished powder aspartame.